Hey guys, I want to do a few problems from section 1.6 so we have time to get through it next week. So yes, it is on word problems, our first set. There will be several different days during this semester when our lessons will be strictly word problems, basically problem solving based on whatever it is we're learning in that unit. So this is going to be some basic one variable word problems that you can solve as of now. Don't worry, I'm going to try to make this as easy as possible on you. I want to tell you exactly what you need to know to be able to solve the problems that you're going to see in Hawks. So hopefully you're not like this guy. Before I start, quick 2 questions I want to review for your quiz, which you're going to be taking today. The first one is this was a type of problem that a lot of folks struggled on in the homework. So a quick review. I believe the biggest issue came out here because of this minus sign right here. So when you're doing this problem, this is a simplifying expressions problem. We're going to start on the inside and work our way out of the parentheses and then the brackets. So the first thing we need to do is we want to distribute this 3 to these 2 terms, but what we have to remember is that there's a minus sign in front of a 3. That means this is really the same as plus negative 3. So what you're really distributing is a negative 3. So in your very first step, which is where most of you messed up who got this wrong, the 9x stays there, oops, and then this is really a negative 3 times 2x. So this is really a minus 6x or a plus negative 6x. Negative 3 times a positive 4 is really a negative 12 or minus 12. And then I have the minus 5 at the end. So that very first step, I think, is where most of you messed up who got this problem wrong in the Hawks. And then once you're done with that, now I need to combine my like terms inside my braces, my brackets. So I'm going to look in here. I have a 9x minus 6x. That gives me 3x there. I have a negative 12 or a minus 12 minus 5. So this is like a plus negative 12 plus negative 5. So a negative 12 and a negative 5 give me a negative 17. So again, you can rewrite it as plus negative 17, or you can just write it as minus 17. And then I have this last part to do that was in front. 4x plus 3x is 7x. And I would write it like this. I'm not in favor of writing plus the negative because then you have to add the parentheses to it. So 7x minus 17 was your answer on that problem. Then the other question that folks had difficulties was on this problem. You might not have had this exact problem, but you had a problem like it. Again, when I go to solve this, I'm going to distribute the 3. And when I do that, I get 12x minus 12 is equal to 12x minus 12. Okay. So some of you went probably a step further. You started subtracting 12x from both sides. When you do that, you end up with negative 12 equals negative 12. Or even if you just look at it at this point, what I notice is that both sides of the equation are exactly the same. Anytime you get an equation and both sides are exactly the same at any step in the process, at this step or at this step, or if you had 12x equals 12x or you have 0 equals 0, at any point, that tells you that there are an infinite number of solutions. Some of you, remember you had a choice of writing one solution, no solutions, or an infinite number of solutions. Some of you got this backwards. So depending on the equation that you got, if you come up with exactly the same thing on both sides, then there are an infinite number of solutions. If you were doing a problem like this and you came up at the end and you got something like this, remember if you get to that and there's no answers, as false statement, that means that there are no solutions. It's the empty set. So some of you had that backwards in your homework, so I wanted to go over that. If you come up to the point where it's a false statement, there are no solutions. If you come up with it being a true statement, even when your variables are gone, it's still true, then that is an infinite number of solutions. So I just want to do maybe 2 problems with you today. We're going to do more problems like this on Thursday, and then we have another whole section to do. So I just wanted to get started on it today. So first of all, strategies for solving word problems. I'm guessing a lot of you have struggled with word problems because that seems to be something that everybody struggles with, right? So make sure, again, read the problem and make sure you really understand what are they telling you? What are you given in the problem and what are you looking for? Okay, restate it. Try to understand it in terms of a picture or a thought. Try to relate it to real life, something like that if you can, to make it make more sense to you. When you make your plan, make sure that you specifically write down in your work, what does the variable stand for? I promise you this will help because if you write down what the variable stands for, like X stands for the small number, or X stands for, the first number, or P stands for the perimeter of the square. If you do things like that, it's going to help you then figure out what else you need to know, what else you already know. And it'll also, when you get done, you'll know which number you actually found, what it stands for. Otherwise, you won't remember what X stood for at the beginning and you'll have to go and figure it out. So just write it down right from the beginning. If you can draw a diagram, if there's a picture, if it's about a geometry shape, you can do that. You can write a chart. I'm going to show you how to make a chart and draw a diagram for the one type of problem you're going to have to do. And I highly, highly, highly suggest you do that. Okay. Then you can write your equation, then you solve the equation, and then check your answers. Again, if you want this list of chart of words, you just have to be careful because sometimes it depends how you use the word in the problem. The word sum could be in a problem and it could have to be a subtraction problem. So it sort of depends on how these words are used. But this is what it tells you, like the sum is the answer to an addition problem, right? So it generally means there's going to be an addition in there, but it depends how you set it up because we know you use subtraction to solve addition. If you see of with fractions like half of something, that means multiplication. So half of would mean 1/2 times something. Twice means 2 times something. Okay. Is another one always means equals. So in the first set of problems we're going to be doing, you can really go straight from the words into an equation. If using these sort of keywords, it'll help you write your equation. So here's example number 1. Our problem is that the sum of two numbers is 36. If half the smaller number is equal to 1/4 of the larger number, find the two numbers. So going through our steps, the first thing I need to do is I'm going to read it to myself as I just did. I'm going to look at the words. I've got a sum word here, so that means the addition of two numbers. When I add them, I get 36. And half the smaller number is equal to 1/4 the larger number. So I've obviously got two numbers here. Now we're only doing equations with one variable right now. Later in the semester, we'll do two variable equations, but right now you can only have one variable. So you need to decide what your variable is going to stand for. You can make your variable stand for the smaller number or the bigger number. The other thing I forgot to mention, so you've got the word of here. Remember, of means multiplication. So when I say, whoops, 1/4 of right here, that means 1/4 times, and right here, 1/2 of means 1/2 times. Okay, so I need to assign my variables. Sorry, that's where I was going before. And I can choose the smaller number or the larger number. I'm going to choose the smaller number. So I'm going to let X be the smaller number. Now, this is where some kids get stuck. What you have to think about is, I know I have a smaller number and a larger number, and I know when I add them together, my answer is 36. So think about it. If the smaller number was 10, whoops, put it over here, 10, I know they add to 36, right? They add to 36. So if the smaller number is 10, that means the bigger number must be 26, right? Because 10 plus 26 equals 36. If the one number was 5, then I know the other number has to be 31 because together they add to 36. So if this number is X, you have to say to yourself, how am I getting the bigger number? Well, what I'm doing, how do I get this number when I know this number and this number, these two numbers? I'm taking 36 minus 5 to get 31. So if I know one number is X, I know the other number is 36 minus X. So it helps to write both of your variable terms. So my smaller number is my x, and my larger number is 36 minus x. If you didn't get that, rewind and go look at that little explanation again and see if you can get it. Try a different number. Try 2, try 8, try whatever you want as a smaller number and see how you get that from the larger number, from the total. So now I'm going to write an equation from the words relates my given information. So the first sentence in my problem told me one number is x, the other number is 36 minus x. Now I'm going to write my equation. So the words said half of the smaller number. So that tells me half, remember, of means times. Okay, that means multiplication. Half times the smaller number is equal to means the equal sign, right? 1/4 of the larger number means 1/4 times the larger number. So I'm going to write this into an equation. So I'm going to write 1/2 times x, because x was the smaller number, is equal to 1/4 of the larger number. The larger number is right here, is 36 minus x. So that's that expression. So this is my equation. 1/2 x equals 1/4 times 36 minus x. So now I'm going to solve it. So to solve this, I'm going to use that technique I taught you last week, which is let's get rid of the fractions by multiplying by the common denominator. The common denominator here for 2 and 4 will be 4. You could use 8, but that makes your numbers even bigger. So let's just use 4. So I'm going to multiply both sides of my equation by 4. When I multiply by 4, that's the same as 4 over 1. Whoops. So when I multiply by 4, I'm going to get that out of the way for you. This is going to cancel out. This, because 4 divided by 4 is 1, and 4 divided by 4, divided by 2, that shouldn't be a 4, that should be a 1. 4 divided by 2 is 2. Sorry, that should not have been there. Okay, so I multiply both sides by 4, and I got 2x, this 2 right here, 2 times x gives me 2x. The 4's cancel out, so I end up with 1 times 36 minus x, which is just 36 minus x. My last step is going to be to add x to both sides, right here, because I want to move that to the other side. So I'm adding x. That's where this 3x came from. I get 3x equals 36. Now I can divide both sides by 3. And that gives me x equals 12. And then I have to go back all the way to the beginning and I say, what did I identify x to be? Well, x was the smaller number. And what did it ask me to find? It asked me to find both numbers. So x equals 12 is the smaller number, but now how do I find the bigger number? Remember what it was? It was 36 minus x. So 36 minus x means 36 minus 12. 36 minus 12 is 24. So the larger number is 24. So my two numbers are 12 and 24. Those would be my answers. Do those numbers work? Well, if the numbers are 12 and 24, let's go back. Do they sum to 36? Yes, they add to 36. And half of the smaller number, so half of 12 is 6, is equal to 1/4 of the larger number. 1/4 of 24 is also 6, so it works. All right, and one more type of word problem, and then we'll do the rest on Thursday. So this is a distance, rate, time problem. A motorist averaged 45 miles per hour for the first part of a trip, 54 miles per hour for the last part of a trip. The total trip of 303 miles took 6 hours. What was the time for each part? Okay, so reading that again, think about it. That's as if I'm like going to just sort of draw what this looks like to me. So I have a car here. I'm not going to draw a very good car, but there's my car, right? So my guy is going to go on a trip. For the first part of the trip, he's averaging 45 miles an hour. So he must have been like on the country roads or something, right? Then all of a sudden he hits the highway. And for the last part of the trip, he's averaging 54 miles per hour. Okay, and then he gets to his destination. So that's his rate on both parts. I know the total trip was 303 miles, and it took 6 hours total. Okay. Then I go and say, what am I looking for? Well, I'm looking for the time, looking for what time it took to make each part of the trip. So what's being asked for is time. So I need to use my variables to stand for the time for each part of the trip. Again, only using one variable right now. So if t is the time for the first part of the trip, then I have to say, what do I know about t that'll allow me to figure out the second part of the trip? Well, what I know is that the total trip was 6 hours. So if the first part of the trip was 1 hour, the last part was 5. If the first part was 2, the last part was 4, right? So if I think about those numbers in what those real life numbers would look like, if it was 1 hour, that was 5 for the rest, 2 was 4. If the first part was 3, the last part was 3. How am I getting those numbers from t? This is t right here. Well, how I'm getting those numbers is I'm taking t and I'm subtracting it from 6, right? That's where the second part of the trip number comes from. So the time for the second part of the trip is 6 minus t. Whatever t was, I subtracted that from 6, and that gave me the second part of the trip. So that's the first part of this problem, is figuring out what the variables are and what they stand for. Now I need to write an equation. Well, is there some sort of equation that relates the variables in this problem? Why, yes, there is. Thanks for asking. The equation is the distance equation. And there is an equation that says rate times time is equal to distance. And rate in this case means like the speed you're going, right? So that's an equation that we can use to write an equation up here. So what I'm doing is I'm going to make a chart. And I would suggest when you get to this type of problem in HAWX that you make a chart just like this. So you're going to make a chart. You're going to have a first part of the trip and the second part of the trip, and you're going to put rate times time equals distance at the top of the chart. So you're going to want to make a chart exactly like this. All right. And then you're going to fill in the pieces that you were given in the problem. In the problem, I was given that the first part, rate, speed, was 45 miles an hour. I don't know the time for the first part, but I decided that that was represented by t, which means my distance is going to be given by this rate times this time. So 45 times t. So this last column you're filling in by taking the first column number times the second column number, 45 times t. In the second part of the trip, I know his rate was 54 miles an hour. The time we just said was 6 minus t. We did that on the last slide. So the distance is given by the formula. So I'm just going to take this block times this block, and that's what I put in this block here. This block is equal to 54 times 6 minus t. Now, what I know about this problem is that the whole distance, or the whole trip, took 303 miles. That's the last piece of information I haven't used yet. So to write my equation, I'm going to say that I know this is the distance on the first part. See, that's what this represents, distance. So the distance from the first part plus the distance from the second part has to equal the total distance. Think about that. The first part plus the second part, distance, has to equal the total distance. So that's how we're going to write our equation. So our equation is going to be that 45t, that was the first block, plus the second block is equal to the 303, which is the total distance. Now we can solve the equation. To solve this equation, I'm going to distribute the 54. I'm going to distribute the 54. That gives me this equation. And then I look at this, and I've got a 45t and a minus 54t. So I combine those. They're on the same side of the equal sign. That gives me a minus 9t. Then I'm going to subtract 324 from both sides. 303 minus 324 is equal to negative 21. So I get negative 9t equals negative 21. And that gives me some ugly fraction, 7/3. So the first part of the trip, time, remember I'm finding the time, the first part of the trip took 7/3 of an hour. In other words, so 3 goes into 7 2 times with 1 left over. So this is the same as 2 1/3 hour. And I believe our original equation asked Also, we had to find out the second part of the trip. So I know if the first part of the trip is this, remember my original equation. The second part of the trip is 6 minus whatever that is. So I do 6 minus 7/3, and I get 11/3, which is also 3 2/3. You can write either answer in Hawks. It does not tell you that you have to put it in as a mixed number. So you can just rewrite it. You can write it in as an improper fraction. It may not accept it as a decimal because this decimal isn't exact. So it might not accept that. I'm not sure. And that's our second type of problem. So I'm going to stop there. We're going to do the rest of the problems on Thursday. So